Architect Ledger TV Spark. On Kubernetes. Spoken section. Your Spark job just crashed at 3 a.m. Memory error. Kubernetes cluster is fine. Data pipeline is fine. So what actually broke? I'm your host on Architect Ledger TV. Today we're diving deep into the two misconfigurations that keep taking down Spark on Kubernetes. Headline: Understanding Spark's memory architecture on Kubernetes. Here is how it breaks down. Spark has two separate memory pools: Executor memory for actual task work, and overhead memory for JVM internals, network buffers, and garbage collection. In plain English, Executor memory is what your code sees. Overhead is the invisible tax Kubernetes doesn't track. On bare metal, you could fudge this. On Kubernetes, that detail matters because pods have hard memory limits. If Executor plus overhead exceeds your pod request, you hit OOM. The point is crystal clear. Spark's memory model and Kubernetes cgroup limits are not naturally aligned. You have to actively bridge that gap. Headline: Misconfiguration 1. Executor memory oversizing. That brings us to the first trap. Engineers set Spark executor.memory to something aggressive, say 8 GB, without calculating overhead. Spark defaults overhead to 10% of executor memory, but that's often too low for real workloads. You end up with 8 GB executor plus 1.6 GB overhead, requesting 9.6 GB from Kubernetes. But if you only set the pod memory limit to 9 GB, boom, out of memory. In plain English, the pod gets squeezed between what it's actually using and what Kubernetes allows. That detail matters because you can't see this mismatch until the job dies under load. Headline: Misconfiguration 2. Heap size and driver conflicts. But here is the catch. The driver pod has its own memory story. If you set driver memory too high without a corresponding Kubernetes memory request, or if you don't account for driver overhead the same way you do executors, the driver itself becomes the failure point. The point is crystal clear. Driver and executor memory are configured in two completely different places: Spark config and Kubernetes manifests. And they almost never talk to each other. That brings us to the real issue. You need a single source of truth. Engineers forget one side, and the whole job collapses. Headline: Solving it. Alignment and observability. Here is how it breaks down. First, calculate total memory. Executor memory plus overhead plus a safety margin. Second, set your Kubernetes memory request to that number. Third, do the same for the driver. Fourth, use Kubernetes resource metrics and Spark event logs together to validate you're not hitting the limit. In plain English, you need visibility into what Spark is actually using versus what Kubernetes thinks it can allocate. That detail matters because a 5% miscalculation cascades into 3 a.m. incidents. The point is crystal clear. Treating Spark memory config as separate from Kubernetes config is a false economy. Two simple misconfigurations. Infinite pain. Align your memory layers, monitor both sides, and your pipelines stay alive. Subscribe for more. Here's the question. How many of your Spark jobs are actually crashing silently right now? End spoken section.